So when we actually look for our FGX component on an inclined plane, we have to use trigonometry, and that means that if we're looking for this side right here, if we're looking for this side, okay, and this is our angle and this is our hypotenuse, we will be using sine to find the x component. All right? So on an inclined plane problem, only on an inclined plane problem, when you are trying to break down the force of gravity into its x and its y components, you must use SOHCAHTOA or SOHCAHTOA, and you will see that in order to find FGX, we're going to use the hypotenuse for the central angle here and the opposite side, which implies that it's going to be FG sine theta. We break that down further into mg sine theta, because that essentially is what FG is. All right? The opposite can be said about FGY. When we look at FGY, okay, so when we look at this side right here, we're using the hypotenuse, we're using the angle, and we're using the adjacent side. So when we look at SOHCAHTOA, we see that that is in fact cos. So FGY here is going to then be FG cos theta, which is broken down into mg cos theta. Now, this switch up in terms of vector components is only true when we're doing an inclined plane problem. Okay, if we are doing a horizontal problem here, and what I mean by that is if I've got a box and I'm dragging that box by a rope, so I've got a force of tension, okay, then I'm still going to be using my x component and my y component the way we learned it first, where x is going to be cos and y is going to be sine. Okay, the only time that that is switched up is in an inclined plane. So if we look back at the values that were given, we have our drive force, we have our mass, and that's about it. We have the angle of elevation of 20 degrees. We have enough information there to determine what the actual FX or FF is, because we can calculate our FGX, we can calculate our normal force, we can calculate our FGY, which means that leaves us with one unknown variable. All right? So if we look at this problem, we already know, looking at the sum of all of the forces here, that we're not going to use any of the forces in the y. So that actually cancels out our Fn and our Fgy. We're not going to need them. We know that this object is traveling at constant velocity, which means that the sum of all the forces, the resultant force, is equal to 0. So if we take this data, okay, we can actually solve for this right now. So what is one of the first things we have to do here when we're looking for our force of friction? We have to look at all of the forces that are playing in the x. What are all of the forces that are at play? If I look at this diagram, what are all of the forces at play in the x? We know that FGX is there. We know that FD is there. And we're looking for FF. Okay, so if we go back to this, we know that our resultant force, okay, is going to be the sum of all of these forces. FGX plus FF. And we know that if this is a constant velocity, this is 0. Correct? Now, can I calculate my FGX? If I go back to the first page, I know that because of the incline, I'm going to have to use sine instead of cos to get my x component. So here, 0 is going to be equal to FD, okay? It's also going to be plus FGX plus FF. Now, if we look at our actual x and y axis, is FF positive or negative? FF is going to be negative in this diagram. Is FGX going to be positive or negative? Is FD going to be positive or negative? It is going to be positive, right? So, if I sit here and I say FD, all right, is then equal to, and I bring these two guys over to the other side, their negatives then become positives, do they not? Because what I can do here is I can say that 0 is going to be equal to a positive FD minus an FGX minus an FF, is it not? If we assign our actual values to this, yes? All right, so if I want to isolate FF, what can I do? If I want to isolate FF, yep. Go ahead, Cecilia. Okay, so I'm going to bring FF over to this side, just because I want it to be nice and positive. I just want an amount here. FF is then going to be equal to FD minus FGX, is it not? So let's actually do the math here. Do we have FD?
Yes.
We sure do. We'll input that later. All right? Minus, now how do I break FGX down? How do I actually get a numerical value for FGX? Yeah?
We do the mass of the object times 9.8 newtons per kilogram times sine of 20.
Is everyone in agreement with that? That's exactly right. So if I want to input some numbers now, I've got 900 newtons minus the mass of the object, which is going to be kilograms times 9.8 newtons per kilogram times the sine of 20 degrees. So have somebody work that out. Did we end up using the coefficient of friction to actually solve for the force of friction? No, we didn't. So this is another way to actually solve for a friction force and where you don't necessarily need a coefficient of friction. Okay? Simply because it's one of the forces at play in this situation, in this free body diagram. All right?